Good morning, dear students. Today we are having the 16th practical lesson. Today we will solve differential equations. We will solve systems of differential equations. And let us start with the first task. Let me share my screen. Just a moment. Okay, shared. So we have okay, task 1A, having the following system of differential equations. Let me write it down. So d to d2x by dt twice equals y, and d2y by dt twice equals x. So we received the following system. So we have the following system of differential equations. So the order of the system, how to um, define the order. The order of the system of differential equations will be the sum of the highest orders of derivatives. So we have the second derivative for the function x and the second derivative for function y. So the order of the system equals 4. We will use elimination method. So we will eliminate one of derivatives. And in such way, we will transform initial system to the equation of the fourth order. So how we will exclude the variable? How we will eliminate the derivative, one of derivatives? The idea is the following. Well, I want to exclude d2y by dt twice. How to do it? I will differentiate the first equation twice. Okay, where all these arrows? Oh, well, yeah, so they were collapsed. So differentiating the first equation. So if I differentiate the first equation twice, I will receive the following. So d for x by dt 4 times equals so the second derivative of y. So I received the following differential equation. So if I substitute the second derivative, so if I substitute this derivative instead of uh, derivative for y, so I receive the following equation. And let me write down, let me move everything to the left part. So I received so the fourth derivative of x minus x equals 0. So here is the linear homogeneous equation of the fourth order. So let us solve it. So r in power of 4 minus 1 equals 0. Okay. Let us use k variable, so it is more convenient for us. So if I factorize this equation, I will receive k square plus 1 by k minus 1 k plus 1 equals 0. So received the following roots. K 1, 2 equal plus minus I, and k 3, 4 equal they equal plus minus 1. So received the following solution for x. So x will be equal c1 cosine of t plus c2 sine of t plus c3 e in power of t plus c plus c4 e in power of minus t. So received x, and what else we need to find? We need to find y. How to find y? We can find it from this equation. So we will differentiate x twice. So dx by dt will be equal minus c1 sine of t plus c2 cosine of t plus c3 e in power of t. Where to move it? Okay, let me move it to the top. And minus c4 e in power of minus t. So finding the second derivative. So the following expression, minus c1 cosine of t minus c2 sine of t plus c3 e in power of t and plus c4 e in power of minus t. And it equals y. So the final answer will be written in the following form. So x equals this expression, and y equals this expression. So this is the solution of the system of differential equations. Any questions about this exercise?
No.
No questions. Okay, let us move next. So we'll check what else. Okay, let me look which examples do we have else. And okay, let us solve one more example from the first exercise. So 1b. Actually, this the second equation will be simpler because we don't have to differentiate such many times. But anyway, so yeah, we will again use the elimination method. So dx by dt equals x plus 2y. Then dy by dt equals 4x plus 3y. So what we will exclude? We will exclude dy by dt. So we will actually exclude y. So let us differentiate the first equation. So d2x by dt twice equals dx by dt plus 2 dy by dt. And let us express, so now I will express y as, okay, Yeah, so y will be equal. Okay, let me write here. So y will be equal 1/3. Stop. No. Y will be expressed from this equation. So y equals 1/2 dx by dt minus x. And then dy by dt will be equal okay, let me do like this. So dy by dt equals 1/2. So d 2x by dt twice minus dx by dt, and it will be divided by 2. Yeah, so expressed y and the first derivative for y. So, and I will substitute these expressions into this equation. So,
But the dt under the dy in the first row, third column.
thank you for your attention. Yeah. By the way, these keys are one near each other. So, what do we actually have? So dy by dt. Stop. Let me check here. Yeah, something is not really correct. Yeah, I substitute everything into this equation. So, what do I have? So, instead of dy by dt, so this, and here for x plus 3/2, this expression. Yeah, so now everything is correct. And now I will expand brackets and simplify everything that I can simplify. So 1/2 d 2x minus by dt twice minus 1/2 dx by dt equals 4x minus plus 3/2 dx by dt and minus 3/2x. Okay, now let's move everything to the left side. Minus 2 minus 2 first derivatives and minus 5/2 x equals 0. So let's now multiply everything by 2. So it will be much more simple. So received the following a linear homogeneous equation with constant coefficients and multiplied by 2, not divide. So yeah, now it's correct. So let us solve this equation. So the characteristic equation is the following: k square minus 4 dx by dt. Stop. Minus 4k minus 5 equals 0. So what the solution will be? So k 1 equals minus 1, and k2 equals 5. I'll stop. No. Something is minus 4k. Yeah, that's, I'm thinking what is not correct. Yeah, so now correct. So x will be equal c1 e in power of minus t plus c2 e in power of 5t. Then finding y. So y can be expressed from this equation. So let us differentiate x twice. No, we can differentiate it once. So we will receive it from this equation. So dx by dt equals minus c1 e in power of minus t plus 5c2 e in power of 5t. Then y equals this expression, so let us substitute it into the initial equation. So first derivative minus x minus will be here. So it will be equal 1 over 2, and what I have here, so what minus 2c1 e in power of minus t, and plus 4c2 e in power of 5t. And if I divide by 2, I will receive minus c1 e in power of minus t plus 2c2 e in power of 5t. So the final answer will be the following. So dx by dt will be found. Okay, stop. It is a derivative, but I need function. So x equals this expression, so c1 e in power of t plus c2 e in power of 5t, and y equals minus c1 e in power of minus t plus 2c2 e in power of 5t. This is the final answer. Any questions about this exercise?
No questions.
Okay, if no questions, so let us move next to the next exercise, and we will find the general solution of this system of differential equations using Euler's method. So how we will solve it? First of all, of course, we will write down the system. So dx by dt equals x plus 2y. Then dy by dt equals 4x plus 3y. And how to solve it? So let us set up the system of matrix of these coefficients, so coefficients before zero derivatives, so before functions x and y in both equations. We will find eigenvalues and eigenvectors. So 1, 2, 4, and 3. So writing down characteristic equation. One minus lambda, 2, 4, 3 minus lambda equals 0. So continue solving this equation. Minus 8 equals 0. Expanding brackets, so 2, and then so minus 2, minus 1, so 2 minus 3 lambda plus lambda square minus 8 equals 0. So continuing simplifying it. So
maybe we multiply by 3 minus lambda.
Yeah, nice catch. Thanks. So 3, and here will be so minus 4 lambda, and here will be 3. Yeah, thank you for your attention. So lambda square minus 4 lambda minus 5 equals 0. So we will find then that yeah, so received 2 simple roots of the characteristic equation. So lambda 1 equals minus 1, and lambda 2 equals 5. So simple roots. So finding eigenvectors for lambda 1 equals minus 1. So we will receive the following matrix. So here will be 2, and here will be 4. And actually we will receive, yeah, so this matrix will be equivalent to the following matrix. So 1, 1, and here 0, 0. So therefore x1 equals x2, or maybe, okay, now let us use here x1 and x2 equals minus x2, sorry. So the eigenvector will be equal, okay, how I mark it here, because a lot of y, okay, y1 lambda 1. Y lambda 1 so let it be equal 1 minus 1, so we can choose so any c, but it will be simpler to do like this, so 1 and minus 1. So done for the lambda 1, and what about lambda 2? So how the matrix will look like? So here will be minus 4, and here minus 2. So receiving the following matrix. So here will be 0, 0, and here 2, and -1. So x 1 equals 1 over 2, x 2. So y with index lambda 1, lambda 2. Okay, let me copy and paste it. So 1 and 1 over 2. So let stop. Yeah, so forgot that x2 is actually a basis variable, so yeah. So okay, let us better, yeah, so x2 we assign 1, and x1 will be equal 2. Stop. Stop. By the way, yeah, so if I substitute 2 here, I receive 1 here. So now everything is okay. So how to write down the generic solution? So it will have the following form. So C1, it will be written in vector form. C1 multiplied by Y1 and E in power of minus t, so in power of minus lambda t. So here minus lambda, so E in power of lambda 1t. And for the second, so C2, Y lambda 2, E in power of lambda 2, lambda 2t, so E in power of 5t. So now let us expand it. Yeah, so we'll write down it in actually it is written in the vector form. And let us write more in more detailed view. So C1 and here 1 minus 1 E in power of minus t plus C2. And I will substitute this vector. So if I so if I add and multiply everything, I will receive such vector column. So I will receive here C1 E in power over minus t plus C2 E in power over 5t. And here minus C1 E in power of minus t plus 2C2 E in power of 5t. And actually, what do we have in this vector? This is x and this is y. So, so the first function, the second. So I can write down the solution like this. So x equals this expression, and y equals this expression. So any questions about this exercise?
No questions.
Okay, if no questions, moving to the next. Okay, let us solve. Okay, let me see. To B or to C, what is more interesting for us? Okay, both cases are interesting. So let us solve both of them. So all of them. So the next system is the following. So, okay, I will skip some some stages when finding eigenvalues and eigenvectors, and pay more attention to solving differential equations. So dx by dt equals x plus y, and dy by dt equals minus 2x plus 3y. So the matrix is the following. 1, 1, minus 2, and 3. Okay. And writing down the characteristic equation. So here will be 1 minus lambda and 3 minus lambda equals 0. And I will skip the calculation of the determinant and so on. And we will find that so it is the pair of complex conjugate roots. So equals 2 plus minus I. Okay, found it. And for the first lambda 4 plus I. So again, so now I will not spend time for solving this system of equations. I will just so I will just write down that y, so vector y for this lambda, for lambda 1 will be equal 1 and 1 plus I. Actually, yeah, so we can write down in like this for now. So how the generic solution will be found? Actually, for 2 minus I will be the analogical stuff. So so finding the following stuff. So y a lambda multiplied by e in power over 2 plus I t. Now let me write down like this. So let me expand this exponent. So I will have e in power over 2t by e in power over it. Then I will rewrite it e in power of t like cosine and sine of t. So this will be trigonometric form. So cosine of t plus e sine of t. Then moving it, so cosine of t and sine of t into, so multiplying by this expression. So moving here, and here I will receive this, and plus I cosine of t minus sine of t, and e in power of t. Then let me write down separately complex and a real and imaginary part. So cosine of t minus sine of t plus I sine of t minus cosine of t. So
But you wrote plus cosine of t.
plus what?
There is. Oh, sorry. You told minus cosine of t, and I confused now.
Ah, yeah, sorry, my bad, yeah. So, just,
I confused cosine with sine.
I understand it. Yeah, I confused as well as we see. So, received the following expression, and now let's also move I out of brackets. So received the following expression. Then, how will we find the so both of this solution? So for so x1, yeah. So we will actually split it to a real and imaginary part. But yeah, actually we already did it. So we split to both imaginary part and real part. And let us, so now we will use, so write like this. So x for a lambda that corresponds lambda 1 equals real part of this x. So x lambda. So we have the following answer. Then for x lambda 2, it will be imaginary part of x lambda. So this part. And again, so the generic solution will look like this. So x from t, so c1 lambda by x lambda 1 plus c2 by x lambda 2. And it will be equal the following stuff. Okay, let me duplicate it. So this part, so substituting here and substituting here. And if I everything write in a more compact way, so if I add everything and multiply, so C1. Okay, let me write down like this. So e in power of 2t, C1 cosine of t, plus C2 sine of t. And here as well, e in power of 2t, C1. Okay, let me write down like this. So C1 plus C2 cosine of t, and plus minus C1 plus C2 sine of t. And also the solution of the system can be written in the following form. So x equals this expression, and y equals this expression. So found. Any questions about this exercise?
No questions.
Okay, if no questions, let's move. Let's solve 2C. So writing down the system. So dx by dt equals 2x minus y, and dy by dt equals 4x plus 6y. So writing down the matrix. So 2 minus 1, 4 and 6. And writing down the characteristic equation. Yeah, so minus lambda minus lambda, and I will receive, let me see what I will receive. So we have the root with the multiplicity equal to 4. So how can we find the solution so of such system? So in this case, it will be equal, so x in power, so x with index lambda equals, so it will be like, so we will receive polynomials multiplied by t. So alpha 1 plus, no, alpha 1 t. No, here is written alpha 1 plus beta 1 t. Okay, let us use invert order of powers. So e in power of 40. Oh, sorry, here alpha 1 plus beta 1. And here will be alpha 2 plus beta 2. So the following solution will be, and how to receive it, we will, how to solve, we will substitute it into the initial equation and use method of undefined coefficients. So we will find undefined coefficients alpha 1 and alpha and beta. Okay. So so dx by dt, so it equals okay, alpha 1 plus beta t, for alpha 1 plus 4 beta t plus beta 1. So differentiated this product, and so 2x here. So substituting this expression and minus this expression multiplied by e in power over 4t. Then dy by dt. So again, differentiating y. So here will be 4, here 4 as well, and plus beta 2 by e in power of 4t. And here it will be equal, okay, so 4x. So 4 alpha 1 plus beta t e in power of 4t and plus 6 this expression. So let us reduce e. So let us cancel it. Stop. Let me cancel it here. So received such system. Again, we will regroup in coefficients. So doing the stuff that you already know, and we will skip these steps. We will just check if it corresponds the system that it is here. So that it is the same. Stop. But yeah, for alpha a alpha 1 a So for alpha 1 plus for beta t plus beta, yeah. So correct, and this one is correct as well. Okay, so let's believe this recordings, and we will just write down that alpha
Sorry.
1. Sorry?
But in your notes, as I see 1 beta 1, but in ours, that in the lesson 4 beta 1.
Here.
4 beta 1 t, but just beta 1.
Mistake here. Here must be beta 1, yeah. And here as well. Yeah, thanks for your attention. Okay, yeah, now everything is correct. Okay, so we will find from this system of equations. Okay, yeah, so these variables alpha and beta 1 are free, so we will assign them values c1 and c2. Beta 2, no, beta 1 equals c2. Then beta 2 equals minus 2c2, and alpha 2 equals minus 2c1 minus c2. So x from t equals the following solution. Okay, let me copy and paste this expression. So here will be c1 plus c1t. Then here c2, here will be minus 2c2. And here the following expression. So if I will write down it in a more convenient way. So x will be equal. Okay, so multiplying it by e in power of 4t. And y equals this expression. So e in power of 4t, and here will be e in power of 4t as well. So any questions about this exercise? Okay, I guess that no questions. So let us have a break, and then we will use other methods of solving systems of differential equations. And now have a break for 5 minutes. Let's continue. So the next task is the following. So task 3, we will have to find the general solution of linear homogeneous equation of linear inhomogeneous system. So before, as you saw, they were inhomogeneous. So this system was the systems were homogeneous because it was not there was not variable t, but here we have it. So the first equation, dx by dt equals 6x plus y plus t. Then dy by dt equals 5x plus 2y plus 1. So we will use two methods. So first of all, eliminating method. So what we will eliminate? Let us eliminate dy by dt. So differentiating the first equation. So we will receive d2x by dt twice equals 6 dx by dt plus dy by dt and plus 1. So then dy by dt equals d2x by dt twice minus 6 dx by dt minus 1. And y will be equal, so y equals so dx by dt minus 6x minus t. So substituting everything into the second equation. So, okay, let me move it here. Okay, now let's substitute into the second equation. So what I have, so the left part, so and it equals 5x plus 2 multiplied by this expression and plus 1. Okay, or maybe, yeah, it, okay, let me move it now here. So now let us expand brackets and simplify the equation, and we will see what do we have. So 2 dx by dt minus 12x minus 2t plus 1. Then, so moving this derivative, so having minus 8 here, and here will be minus 7, moving here will be plus 7x, and moving 1 out of this bracket, so 2t plus 2. Let me check in my notes. Yes, minus t plus 2, yeah, so correct. So we received a linear inhomogeneous equation with respect to x. Solve. Solving first of all characteristic equation. So solving a homogeneous equation. So k square minus 8k plus 7 equals 0. Then k1 equals 1 and k. Stop what I did. So k1 equals 1 and k2 equals 7. So x0 equals c1 e in power of t plus c2 e in power over 7t. So then finding the partial solution, so it will be like a polynomial with yeah, so control number of this function is 0, not root of the characteristic equation. So x with the wave, x partial will be equal t plus b. So differentiating it twice. So x with wave prime equals a, and x partial. So the second derivative will be equal 0. So minus 8a plus 7 at plus b equals minus 2t plus 2. Let me write it from my notes. So yeah, substitution is correct. So we will receive that x partial will be equal minus 2 over 7t minus 2 over 49. So found it.
You wrote
Question?
2 over 7, you wrote t. The last line.
Yeah, and also something with yeah, so wrong sign here, so must be minus. Okay, but let me use another color better. So minus. So yeah, now it's correct. So x equals so sum of homogeneous. So sum of solution of homogeneous equation plus partial solution. And let's find y. So y will is found by this substitution. So let's differentiate x. So it equals c1 e in power of t plus c2 e in power of 7t plus 7c2. Sorry. And minus 2 over 7. So y will be equal this expression minus 6 expression, so minus 6 x and minus t. And if I expand brackets here, yeah, so derivative is correct. So it will be equal so minus 5c1 e in power of t plus c2 e in power over 7t plus 5 over 7t minus 2 over 49. So the general solution will be the following. So x equals this expression, and y equals this expression. So found the solution. Any questions about this exercise?
No.
Okay, no questions. So now let's solve with another method. So 3b. So we will use it with method of selecting the form of the partial solution by the form of the right-hand side. So first of all, writing down the matrix of of coefficients before functions. So we have 6, 1, 5, 2, and vector of the right part. And we can see that it is t1, so it is vector function. So t1. So the first of all, we need to find the generic solution of the correspondent homogeneous system. So erasing this part, so only functions. It is found here with using Euler method. I will so for now we'll skip this part because it is analogical to task 2, and I will receive that so that generic solution is the following. So the general solution, so C1, so 1 minus 5 e in power of t plus C2 1, so 1 e in power of 70. So actually it matches the solution so from the first method. So found. Then how we will find the partial solution? So again, we know that contour numbers of the right part, so control number of the right part is 0 for both of them. So in homogeneous coefficients. So here 0 and 0 because e in power of 0. So the partial solution will be found in the following form. So it will be found as as polynomis with undefined coefficients. So how to find it? So how to find coefficients? We will substitute them into the initial system of equations. So as we can see here, so it is substituted into the initial system, and then it will be found that the partial solution has the following form. So minus 2 over 7t minus 22 over 49. And here 5 over 7t minus 2 over 49. Copy pasting. mistake. And here as well. Yeah, so 2 and 2 here. Okay. So the solution will be the following. Oh, stop. 2/49 and y minus 2/49. Yeah, so it matches. So x will be equal C1 e in power of t plus C2 e in power of 7t. Yes, Stanislav, question?
Is there plus or minus 5/7t plus minus 2/49? Or should we put brackets?
Minus. And y equals minus 5 C1 e in power of t plus C2 e in power of 7t and plus this partial solution. So this is the generic solution of the system. So any questions about this exercise?
No.
Okay, moving to exercise 4. So so now we are solving Cauchy problem. So the system is the following. So dy1 by dt equals 4y 1 minus 5y 2 plus 4t plus 1, and the second equation dy2 by dt equals y1 minus 2y2 plus t. And the initial conditions are the following. So y1 at 0 equals 1 and y2 at 0 equals 2. So the second order of the system, and we have 2 initial conditions. So everything, so we have everything to solve the system. So here we will use method of variation of arbitrary constants. So first of all, let us solve the homogeneous system. So we can use any method, and here is performed Euler method. Okay, I will skip all calculations, and I will receive here that y homogeneous from T will be equal C1 multiplied by a vector 1, 1, and e in power of minus t plus C2 multiplied by vector 5, 1, and e in power over 3t. So found the found solution. Yeah, okay. So found the generic solutions, generic solution of homogeneous equation, homogeneous equation system. And let us so consider C1 and C2 as constants from T. So y 1 equals C1 from T e in power of minus T plus C2 from T plus 5C2 from T multiplied by e in power over 3T. And what about y2? So let us write other coefficients. So y1 and y2. Okay, now let's differentiate them. So y1 equals C1 C1 prime e in power of minus T plus C minus C2 minus C1 e in power over minus T. And here 5C prime e in power of 3T plus 15C2 e in power over 3T. Yeah, and y1 prime. Then what about the second derivative? So y2 y2 prime equals so C so C1. Oh, okay, it will be the same part here. Then plus C2 prime e in power of 3T plus 3C2 e in power of 3T. And what do we next? We substitute these expressions into the initial system of equations. So substituting y prime, substituting y, substituting y1. Okay, let me erase here dependency on t. And here minus 5 this expression. So now using the second equation, so substituting, so y prime to substituted, substituting y1 and substituting y2. So received the following system. Let us compare. Yeah, it seems that it matches with my notes. And now let's just okay, let's skip all steps and we will just receive the solution of the system with respect of C, C1 and C2. So C1 prime equals yeah, and C2 prime. So they equal 1 over 4 t minus 1 e in power of t, and C2 will be equal 1 over 4 3 t plus 1 e in power of minus 3t. So after we integrate this expression, we will receive that so we will receive that C1 equals 1 over 4 t minus 2 e in power of t, and C2 equals minus 1 over 12 3t plus 2 e in power of minus 3t. So now substituting them into these solutions. Yeah, so general solution will be found as sum of partial solution and a solution of a homogeneous system. So let's copy and paste. So for y1, so the solution of homogeneous system plus plus partial. So this expression, and here will be this expression. So minus 5/12. And for this, so let me copy and paste it here. And here we'll erase t already. And doing actually the same stuff. So after simplifying, we will receive the following general solution. So y1. Yeah, so brackets were not expanded. So here just substituted. Okay, let's erase e here. We don't really need it. And there just substituted initial conditions. So if I substitute initial conditions, what will we receive? So the system with respect to C1 and C2. So 1 equals C1 plus 5C2 minus 1/2 minus 5/6. And what about the second equation? So 2 equals C1 plus C2 plus 1 minus 1/2. And minus 1/6. So let's check. Yeah, so it matches, and the final answer will be yeah. So the solution of the system. So with respect to C, so C1 equals 11/4, and C2 equals minus 1/12. So the final solution, the solution of Cauchy problem, is the following. So 11/4 minus 5/12 over 12 in power of 3t. And for this part, so the following stuff. Here will be minus 1/12. And this is the solution of Cauchy problem. Any questions about this exercise?
No.
Okay. So now solving exercise number 5. So what do we have to do here? So we need to find a partial solution to the system. So it means that we don't have to find a general solution, just partial. So how will we do it? So first of all, writing down the system. So dx1 by dt equals minus x x2 plus t square, and dx2 by dt equals x1 plus e in power of t. So how the functions so how inhomogeneous parts look here? So for the first equation, function f1 from t equals t square. For x so f2 equals e in power over t. So polynomial over the second degree and exponent. Then we write down the characteristic equation. So with using these coefficients. So actually the matrix will look like, so we will have the following form. So we would so 0, minus 1, 1, and 0. So the characteristic equation will be so minus lambda, and here minus lambda as well, so equals 0, and we will receive here that lambda equals plus minus I. It equals y, and let us look at control numbers of these coefficients. Let us look at these functions f1 and f2. So control number of f1 is 0, control number of f2 equals 1, and both of them are not roots of the characteristic equation. So the partial solution will be the following. Yeah, so actually for both of them, so we will have the sum of the polynomial of the second degree and exponent. So x1 partial will be equal, okay, let me write down like this. So x1 partial equals a1 at t square plus bt plus c plus okay, b1 t plus c1 plus d plus d1 e in power over t, and analogically to x2, so the following coefficients. And now we will substitute them into the initial equation. But first of all, of course, let us differentiate. So x1 prime equals 2a1 t plus b1 and plus d1 e in power of t. And analogically for the second, but other indices of coefficients. So let us substitute it into the initial equations, into the initial system of equations, and we will receive the following. So substituted derivative and substituted the function. So equals here everywhere minus, 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 and plus e in power of t. Then here substituting derivative, and it equals, okay, substituting x1, and, stop, here is t square, and plus e in power of t. Let us compare with the system. Yeah, actually it matches everything in nodes. And after that, we are using a method of undefined coefficients. So we are finding all these coefficients. Actually, we have like two systems of equations. Oh no, we actually have, yeah, so we have a system of 8 linear algebraic equation with respect to these coefficients. So we have 8 variables, so 8 equations. Actually, these equations are quite easy. So found coefficients, and after that we just write down the partial solution. So x1 equals 2t minus 1 over 2e in power of t, and x2 equals t square minus 2 plus 1 over 2e in power of t. So that's the partial solution. Any questions about this exercise?
No questions.
For now.
Okay, then if you have no questions, so let's maybe any questions about the whole lesson, about previous lessons?
No.
Okay, if absolutely no questions, so let's finish for now. Have a nice day. Stay safe. Thank you for your attention.
Thank you. Goodbye.
Goodbye.
Thank you, goodbye.